All right, we're recording. So I'm going to do this example, which is on the web work, which is, you may have a slightly different example. The cylinder might be sitting upright or something like that. But what we're going to do is integrate. We're going to separate the bounds of integration in order to integrate over this half a cylinder. So the first thing to do here is to fix two of our coordinates and then to ask ourselves what the bounds are for the third coordinate. And what I would advise in this situation is to fix your z and your x and then integrate over y. So we'll think of this inner integral right here as a fixed x and z, and we're going to integrate over the y variable. Now, what are the bounds for y? Well, if I fix my x and my z, you can think of having a particular point in the xz plane, and then what I want to do is move along a line parallel to y. And I want to know what are the bounds for y in terms of x and z as I move along this line and I'm looking at how I go back and forth in this shape. So the bounds will be from the round part on the left side of the cylinder up to this flat part where I've cut off the half of it. So the left side of this cylinder, this cylinder is given by y squared plus z squared equals 4. Yours may be a little bit different, but I've chosen a radius of 2 and a length of 1. So the left part of this cylinder, if I want to know what y goes from, where y starts and where y ends in the left part of the cylinder, I need to solve for y in terms of z, because I fixed my x and my z. So right here, I start, and then I integrate along until I get to right there. And y here would start at square root of the minus square root of 4 minus z squared. So this would be y equals negative square root of 4 minus z squared. That's where y is going to start, and then it's going to stop at y equals 0. So that'll be my first bound. It'll be minus, I'll write in y equals minus square root of 4 minus z squared up to 0. Okay, now I've got that one little, like a little filament in this full shape, and I'd like to drag that filament either back and forth or up and down in order to trace out a sheet in this shape. And so I think dragging it in the x direction works nicely right off the bat. So I think of dragging this thing back and forth. I now have a fixed z. So I think of this, the two inner integrals as having a fixed z. And I'm going to integrate with respect to x next. And so dragging this little filament back and forth, I get a sheet that looks like this. And that sheet takes x from 0 out to x equals 1, because I've assumed that this thing has a total length of 1. So x goes from 0 to 1. Now I finally have to take this sheet and drag it up and down in order to trace out the full shape. And in this case, z is going to start all the way down here at minus 2, because it has a radius of 2. So I'm down here at minus 2. And I drag that sheet all the way up until I get to 2 up here. And so those are my z bounds. Z equals minus 2 to 2. And that's it. Any questions?